Stoichiometry. Let's review the 5 steps of stoichiometry. Step number 1 is to write the chemical equation. Step number 2 is to balance that equation. Step 3 is change grams to moles. Four is use proportions. To go moles to moles. And 5, change moles to grams. Okay, let's review what all this actually means. Okay, write the chemical equation. Right now you know how to write equations for decomposition, composition, and complete combustion. So if the chemical equation is not already written for you, you'll need to use that knowledge from a previous chapter to write out that equation. 2, balance the equation. This is very important because in stoichiometry we use the balancing coefficients to use step number 4 in our proportions. So if it's not balanced, we can't go from moles to moles. So make sure the whole equation is balanced before you begin step 3. Step 3, change grams to moles. In your problem, you'll be given some sort of number, and it's usually in grams. If it's in kilograms, let's make a side note up here. If it's in kilograms, remember to multiply by 1,000 grams in 1 kilogram to change it to grams. Now, you need to convert grams to moles. And we know how to do that by using the AMU of the substance. So if you put your finger on the number in the problem, it'll say so many grams of, and then a chemical. So add up all the AMUs of that chemical. And the AMU unit is also grams per mole. So if we want to change our grams to moles, all we have to do is take our grams and divide by our AMUs, our grams per mole. They'll cross out these 2 units and flip mole up on top. So, number 3, we change grams to moles by dividing by the AMUs of that chemical. Now, use proportions to go moles to moles. Well, we write out whatever number we got on 3, and we put it over the balancing number for that chemical up in from number 2. So let's just put balancing number here. Okay. Now that's going to equal our unknown gram, or no, that's not grams here, sorry, it's moles. We're going to take whatever moles we have from number 3 and put it over the balancing number for that chemical. and then it equals the number of moles of our unknown over unknown's balancing number. Okay. Now we have unknown moles, and we need to change it back to grams. So we take our unknown moles, and then we multiply by the new AMU, or the new grams per mole, another name for AMU, of the new compound that we're trying to figure out. It's the question part of the sentence in the story problem. Like, how many grams of a new compound? So this is the 5 steps of stoichiometry, and let's go ahead and try one of these. Okay, if I add magnesium and water, I get magnesium hydroxide and hydrogen gas. Remember, hydrogen gas is a homonuclear diatomic, so I have to put the 2 there. Now, except for that hydrogen gas, you don't know how to do this reaction yet, so that's why I just wrote it. It's part of the problem. So step 1 is done for you. Let's do step 2. Let's balance this. I have 1 magnesium on the reactant side and 1 on the product side, so that's balanced. I have 2 hydrogens, and then 2 hydrogens plus 2 more hydrogens, so 4 hydrogens on the product side. So I need to come over here to the reactant side and add a 2 in front of water. That means I have 4 hydrogens now. So let's check the oxygen. I have 2 oxygens on the reactant side and 2 in the product side. So it's balanced now. Okay, so steps 1 and steps 2 are done. Now step 3. Let me read the rest of the problem. What mass of magnesium must you use to make 5.6 times 10 to the 4th grams of MgOH2? Okay. All right, so let's go through and kind of talk about this question before we even start trying to answer it. So first, what mass? First, you need to know that mass means grams in chemistry. So it's really asking how many grams, okay? And now I have this number in scientific notation. Let's change that out to a real number, make it easier to work with. So I have 10 to the 4th. That means that I need to multiply this by, okay, 10 squared is 100, 10 cubed is 1,000, so 10 to the 4th is 10,000. I need to multiply 5.6 times 10,000. Well, the easiest way to do that is to move the decimal 4 places. 1, 2, 3, 4. Fill in with my zeros, add my comma, and now I have 56,000 grams. All right, so I know what I need to do. I need to change my step 3 is change my grams into moles. So I need to change 56,000 grams of MgOH2 into moles. Well, first I need to figure out my AMUs of MgOH2. Mg is magnesium, and it weighs 24.3 grams per mole. Oxygen is 16.0 grams per mole, but I have 2 of them because this 2 goes to everything in that parentheses. So I'm going to multiply that weight by 2. Hydrogen is 1.01, and I also need to multiply it by 2. Now, multiplying this out, I have 32 for our oxygens and 2.02 for hydrogens. Let's add all this up. 4, 5, 6, 7, 8, 5, 58.32. Now, when I add significant digits, remember that you draw the wavy line at the least significant, and then I need to round to that place. So I'm going to round that off to 58.3 grams per mole of magnesium hydroxide. So now I need to take my 56,000 and divide by 58.3 grams per mole, and I will get just moles. Okay, using a calculator, that gives us 960.5 grams per mole. Now going back to significant digits, this original number had 2, 1, 2 for this, and then my AMU had 3, so I'm going to use 2 because that's my multiplying dividing rules. So I'm going to round it off to the first 2 significant digits. That would give me 960 grams per mole. Okay. No. I am using the wrong units, aren't I? That would just give me 960 moles. It's a little harder than what it seemed like to make a video, so forgive me if I'm making mistakes. Okay, so that's step 3. I have converted my grams to moles. The next thing I need to do is go from moles to moles using the proportions. Let me erase some on my page so I'll have more room to write. Okay. Now I need to use my proportions to go from moles of MgOH2, and our problem was talking about how many grams of Mg do I need. So I need to go back to the Mg. So I need to put the 960 over the balancing number for that compound. The balancing number up here, well, you don't see 1, and that means that automatically it's an understood 1. So I'm going to put it over 1. That's my perfect recipe. If I have 1 mole of that, I get 1 mole of Mg. So if I have 960 moles, how many moles of Mg will I have? Well, Mg's balancing number, magnesium, is also 1. So, when I cross multiply, I get 960 times 1 equals 1 times x. Well, that's pretty simple, isn't it? That's just 960 equals x. So I also have 960 moles of Mg, magnesium. So that's my step 4. Now my step 5 is to convert 960 moles back into grams of Mg. 960 moles Mg, magnesium, times 23.1, which is the AMU of magnesium, and it's grams per mole of magnesium equals, using my calculator, I got 22,176. And then let's look at significant digits. I have 3 here, 2 here, so my answer needs 2. So I'm going to round that off to 22,000. And that's grams of magnesium. And that is my final answer. Okay, now this is a full stoichiometry problem, going from giving you grams to begin with, and your answer needs to be in grams. But there can also be partial problems. Now, if the question had started with moles, and it gave me this 960 moles of Mg, there would be no reason to do step 3, because it would already be done for you. Or, if my answer for stoichiometry needed to just be in moles, I could have stopped with the 960 moles of magnesium. So every time you go through one of these steps, make sure that you need to do this step before you start. And then also that when you're finished with the step, you're not finished with the whole problem. Because you can start and stop anywhere within these 5 steps that the question tells you. So think about it before you start, and think about it as you're doing it. And that is stoichiometry.